Rate of change part 4. Another example, we have a container taking the shape of right cylinder, sorry, it's not cylinder, right circular cone of height, let's say it's capital H, which is equal to, let's say 15 centimeter, and a base radius 2 centimeter. This base has radius capital R equal 2 centimeter, and is collecting water. Here it's collecting water. This cone is collecting water up to in a rate of 0.1 rate of change of water, 0.1 centimeter cube of per second. This means what is 0.1 centimeter cube per second? It is volume of water, right? To time. Centimeter cube is volume, so it's collecting a volume of water of 0.1 centimeter cube per second. Let me name these points here. This point, let's say it's A, since it's circular, right cone. This angle here is 90. This point over here, let's say it's B. This point over here, it's P. And here I changed the, I made the, let's say here we have radius also, but this is small r, right? This is small r, okay? And let's say this point here is S, and this center of this circle here, the center of the circle over here is point O. Also we have 90 degrees over here. Okay, let's start. Part A of this example. Find the rate at which the height of the water is increasing at any time. We need to find the rate that height of water, which is small h, is increasing at any time. In general, the h over dt is equal to what? At any time. We don't have specific rate, right? At any time. We don't have specific time, right? This means, first, the rate at which the height of water h or depth of water changes depends on the rate of the volume. Height depends on the volume, because the volume is equal to volume of cylindrical cone. It's 1 over 3 pi r square times h, right? So the h, the depth of water, the small h, depends on the volume. This means we need to find the chain rule, which is dv by dt is equal dv dh times dh dt. And we want to find this dv, we want to find the h dt, the height of water at any time. This means we need to find this one here. In order to find the h over dt, we should know what is dv over dt, change of volume in terms of time, and change of volume in terms of height, right? Change of volume in terms of time, it's given already. It is what? 0.1 centimeter cube per second. Change of volume in terms of height, we can find it by using the volume formula in terms of height. So this one here gives us dv to dh equal d of 1 over 3 pi r square h to dt, right? To dt, dv over dh, right? This is not t. We are finding dv to dh. We have already dv over dt. So it is equal to derivative of 1 over 3 pi r square h over dh, right? What is that will be equal to? Okay, we need to find this the derivative of this one here in terms of h. Let's see. Okay, in order to do that, before finding this derivative, before I find this derivative, let me try to find. Let me try to find the radius, the small radius, in terms of the height. What is the small radius in terms of height? Okay, let's look at the figure. Triangle POS and triangle PAB, they are surely similar triangles, right? We have common angle down at P, and we have 90-90, so they are similar. What ratio they have? They will have ratio PO over PA, and it will be equal to OS over AB. In other words, PO is small h, right? Over PA is capital H, and we have it 15 centimeter. Is equal to OS, which is small radius, and over AB, which is capital radius, big R, which is 2 centimeter. So cross product, we will get radius equal 2 over 15 h. Substituting this radius in the volume rule, the volume will be 1 over 3 times pi times radius square, which is 2 over 15 h all square times h, right? So it will be 1 over 3 pi times 4 over 225 h square times h. It's h to the power 3. It's h to the power 3, not r to the power 3. h to the power 3. So at final we have a rule. We have a final answer here, which is this one, right? 1 over, let's multiply it, so it will be 4 over 3 times 225, it will be 675 pi h cubed, right? This one here, let's do now the derivative, dv to the h. dv to the h, it will be equal derivative of this number here. Instead of having h and r, we have only h now, pi h cubed, right, to the h. So it will be equal 3 multiplied with 4 over 675 times the pi r squared, h squared. Again, I'm writing the h as r, h squared. So it will be equal also divided by 3 numerator and denominator, we go back to 225 h pi h squared, and this is dv to the h, right? So what do we have now? We need to find again the dh to dt is equal to dv dt divided by dv dh over dt. It will be equal dv over dt divided by dv over dh. What is dv? Change in volume to time. It's given as 0.1 centimeter cube per second, 0.1 centimeter cube. Let me put the units when we finish. 0.1 over dv dh. What is dv dh? dv dh is equal to 4 over 225 pi h square, right? This is what we got. So by other words, we can make this 0.1 as 1 over 10 over 4 over 225 pi h square in the denominator. So the final answer will be 225, right?